Okay, let's look at example 3, which has this expression, uh, and if the expression above is written in the form a plus bi, where a and b are real numbers, what is the value of a? So in essence, they wanted to rewrite this expression in this form. Now, generally, you see, let's divide this into two. You see these kind of questions when they want you to apply something we call the conjugate. So let's conjugate is nothing but trying to take this the denominator here, which is the base of the fraction, and split it up. So the conjugate of this here will be, actually the conjugate of this will be 3 plus 2i. You're going to see that very soon. Why? Because the conjugate, all you do is you just change the sign of the complex uh, expression right here, the 2i. So if I give you 3 plus 2i over 4 plus 7i, and I want you to express in this form, then all you do is you find a way to take the conjugate of this, which will be equal to 4 minus 7i. Now, once you do the conjugate, then you multiply the conjugate to the numerator and also to the denominator. So in this particular case, we are going to say that 8 minus I divided by 3 minus 2I is the same thing as 8 minus I multiplied by the conjugate, which is 3 plus 2I, and divide by 3 minus 2I, also multiplied by the conjugate 3 plus 2I. Now, if you look at this carefully, you notice that this here cancels this out because it's the same, and therefore the expression here has no change. Now, let's go ahead and simplify this then. Now, this is therefore equal to 8 times this is equal to 24. 8 times this will give you plus 8 times this will give you 16i, minus I times this will give you minus 3i, and then minus 1 times this will give you minus 2i squared, divided by, and then 3 times 3 is equal to 9. 3 times 2i will give you plus 6i, minus 2i times 3 will give you minus 6i, and then minus 2 times this will give you minus 4i squared. Now, let's keep simplifying this. Now, you notice that this is the same thing as, you know, this is 24. This will give me 24. 16i minus 3i will give me plus 13i. And this will give me minus 2 minus 1. So this gives me minus 2. Remember, I squared, actually, let's write it. This is minus 2 minus 1 here, because now I squared is equal to 1 as it was given to us here. If I square both sides, I get I squared is equal to minus 1 from here. So I squared is equal to minus 1. So I can plug it that way, and then that will be divided by 9. As you see, this is where the conjugate comes in. The conjugate, once you do the conjugate, it simplifies the denominator into a rational number. So the complex numbers will go away. So this will go away, and then I have minus 4, and of course this I squared is also minus 1. Then that gives me this, and that is equal to 24 plus 13i plus 2. You see that? Because 2 minus 2 times minus 1 is equal to 2, and then I have 9 minus 4 minus this will give you plus 4, like that. So this whole thing now become 24. This is actually 26 then, because 24 plus 2 26 plus 13i. You divide this one by 9 plus 4 is also 13, and when you divide both sides, so this is 26 divided by 13 will give me 2 plus 13 I. So the whole thing can now be reduced into 2 plus I. Now, since it is 2i, they want you to find, now this is supposed to be equivalent to a plus bi. That means our a is equal to 2 and our b is equal to 1. Right? So in terms of trying to find the value of a, obviously our a is equal to 2. That is how you use a conjugate to resolve these expressions. I mean, you also see this when you're dealing with radicals, and they work pretty well.